Hey calculus folks, I am doing a video here on notes for quotient rule. This is our third rule. You already should know the power rule, which is pretty easy. That's your basic derivative rule. And yesterday we did the product rule, which is when you have two things multiplied, how that works out with derivatives. Our new rule today is called the quotient rule, and it happens whenever you are, quotient is a fancy term for division, just like product was for multiplication. If you ever have one function divided by another function, I know we still use u's and v's, which could be written like each other. Not cool, man. But here's the quotient rule. The quotient rule is v u prime minus u v prime over v squared. Now, this is a more dangerous one to use because of the quotient rule. The reason it's more dangerous than product rule is, with product rule, does it really matter if I switch these two? No, because it's a plus sign. It doesn't even matter if you switch those two or those two, and then the entire pieces with the entire pieces. Because of the plus, it's pretty interchangeable. However, with this minus sign here, it matters that you know what goes first and what goes second, or you'll get the wrong answer. So if you consider this part that's up high, and this is the part that's down low, there's a way to help remember here. Now, Hewlin sings a song. I don't really sing a song, but I do have a little way that helps remember it. Low D high minus high D low over, they'd say the denominator squared, but I'm going to say over low low. All right, low D high minus high D low over low low. Okay, so that means the low part, and the D is for derivative, low part times derivative of the high minus high derivative of the low all over low low, which is the denominator squared. Okay, so that is the formula, and the rest of it is about just differentiating it. So let's do an example or two. Okay, so for example 1, we're going to differentiate this equation. Differentiate is fancy for find the derivative of. So let's try it out. I want to find the derivative of this. So I'm going to think of the whole top as u and the whole bottom as v, or high and low. Okay, and we're going to apply this formula to it. Okay, so the derivative, I'm going to write f prime of x equals, we're going to do low, written exactly it is, times d high. What's the derivative of the high part? Just 3. Minus, yep, high, which is the 3x minus 2. D low, the derivative of the low part is 2. All over low low. So you'll write 2x minus 3. You could write it twice, but it's quicker just to say square. Right? Okay, so now it's just a matter of simplifying, right? I'm going to distribute a 3 into both those pieces up top. So we have 6x minus 9. And here, this is a tricky move. Well, it's not super tricky, but I need to distribute not only the negative sign, but also the 2. So we're going to like rain down upon this with furious vengeance. So basically, I'm going to do the 2 times 3x, which is 6x, and attach the minus sign to it. I'm going to do the 2 times a negative 2, which is negative 4, and attach the negative sign to it, which makes it a plus 4. Have you ever done double distributing before? Well, you haven't lived. Alright, so we're almost there. We're going to combine like terms. Those 6x's go away. Does that happen every time? Actually, not usually, but, you know, enjoy it when it happens. And then a negative 9 plus 4 leaves you with negative 5 on top, and 2x minus 3 squared. Boom. That is it. That's simplified. It's beautiful. If I asked you for the slope of this crazy equation, as x was 5, you would just put a 5 in here and calculate it out. See what happens. Yeah, so that's not bad, right? Let's try another one. All right, so this problem, directions are differentiate and simplify. Sometimes I'll ask you to simplify, sometimes I won't. It's a skill that you should have, but you don't always need it. You need it especially if you're going to take another derivative. And later on we'll learn about that. There's something called a second derivative, where you just take the derivative of the derivative. But that is neither here nor there. All I got to do is use my new rule. When you see a fraction, you want to think of this as your high, this is your low, right? Or your u and your v. You can follow that formula. Okay, so we got low d high. So I'm going to do the derivative of the high part, which is 3x squared plus 3. Okay, minus high, which is x cubed plus 3x plus 2. D low, which is 2x, all over low, which is x squared minus 1 squared. Okay, so now simplify completely means I want to, FOIL this. So we're going to do. Okay, so the numerator here gets pretty big. The denominator I'm just going to leave. Don't FOIL the denominator out. Nobody ever wants that. But the numerator, so we're going to have 3x to the fourth for first times first. Outer is going to be plus 3x squared. Inner is minus 3x squared. And last times last is minus 3. And then I got to, instead of doing 2 of them, here's something else you can do. You know how we did the double distributing? Here's something else you can do. You can just change this to a plus as long as you change each one of these. Not all of them. Don't change that one, or it's like negative times a negative. If I distribute that negative sign and make each one of these the opposite sign, then I don't have to do 2 steps at once. Now I can just freely send this 2x into play. So we're going to have 2x times negative x to the third, which is minus 2x to the fourth, right? And this guy here, you're going to have minus 6x squared, and here you'll have minus 4x. Okay, so now it's about combining like terms. So how many x to the fourth do I have? I have this guy and this guy. I got 3 of them, minus 2 of them leaves you with 1 of them. Okay, and then we look at, there's no x to the thirds, but I do have a bunch of x squareds. Those two kill each other though, so I'm just left with minus 6x squared. And then I look for x's. Here's an x, so minus 4x. And I do have a constant floating around here, minus 3. All over x squared minus 1 squared. And if the top factored further, you would, but it's a difference of 2 squares. It doesn't, or not difference of 2 squares. You could try factor by grouping, but it doesn't work. So that's it. That's simplified. That is the equation of the slope of this line at any point, which is crazy that we can find that. It's actually pretty neat. Let's try another one. All right, so sometimes I'll write directions, find the derivative first step only. That means I don't want you to go through all the steps of simplifying because they're not always necessary. Here is a problem that you could do a much harder way. I call them combo problems, or you could do it an easier way. Work smarter, not harder. So on this one, this is where we start to have to use multiple rules. Okay, so if you look at this, you really have 2 options. I can treat this problem like a product rule that has a quotient inside of it, or if I want to, I can turn this to over 1 and smash the 2 tops together and smash the 2 bottoms together and treat it like a quotient rule that has a product in it. Now, since this day is about the quotient rule, I'm going to do that. A different day will change it up. But notice I wrote f of x because I'm not taking the derivative of it right now. I'm just simply rewriting my problem in a nicer form. This is actually what I would call a combination problem. This is kind of mean, but The entire top is what I would consider my u. The entire bottom is what I would consider my v. So this is why I said I only want the first step derivative, because this thing gets a little crazy. Now you have two options at this point. You can either do the quotient rule and realize when you do the d high, when you do the derivative at the top, you're going to have to do a product rule. Or you can FOIL like crazy now and make your life easier later on. If it were me, I don't know, I'd probably just FOIL right now. And we'll save the other type of problem for later. So let's have a festival of foiling here. Yeah, let's do that, because I don't want to do the product rule and the quotient rule yet. We'll save that for later. Okay, I'm going to write this all the way out. So basically, this x squared has to travel to all three of those first. So we're going to have x squared, x to the fourth, plus x to the third, plus x. Okay, then we're going to take the negative x, make sure you take that negative with it, to all three of those. So we're going to have negative x cubed is the first times, or the middle times the first. Now middle times middle is negative x squared and negative x. And then we'll do the last times all three of those. And you got a negative 3 going through. So we're going to do minus 3x squareds minus 3x minus 3. So that's a lot of junk, right? Notice I have not yet taken a derivative. I haven't done my rule yet, so I'm not changing my sign to an f prime of x. I just got to collect all my terms. So I have x to the fourth, and then let's collect all the x to the thirds. We got a positive one and a negative one. They'll kill each other. So I guess that makes those go away. All the x squareds, I have a negative x squared and a negative 3. That makes negative 4 of them, doesn't it? Oh no, hold the phone here. This one should have been an x squared. Gosh darn it. I knew there's something wrong there. My first times my 1 should have been an x squared. Okay, let's try that again. This kills that, and you're left with just a minus 3x squared. And then the x's, I got a negative 3x and a negative x, so minus 4x, and then a minus 3. All right, that looks better. I mean, that was irritating, yes, but I would much rather call this my u and this my v, and now I can take my derivative. So I'm going to do, finally, just do this. Just get extra paper here. So I'm going to go f prime of x equals low d high. What's the derivative of the high part? 4x to the third minus 6x minus 4. That's low d high minus high, which is this ugly thing, x to the fourth, 3x squared minus 4x minus 3. Oops. D high, what's the d low? Low d high minus high d low. That's just 2x, right? Nothing crazy there. And it's all over low, which would be x squared plus 1 squared. Now, since I said first step only, you're done here. Don't keep on keeping on. If I would have said simplify completely, you would have had to FOIL this one out. You'd have to FOIL the 2x and the minus sign and simplify it down. Which, could you do it? Yes. Do you want to do it? Probably not. And why do I stop here sometimes? Because if I don't need to go to second derivative, then it's kind of just a waste of time to do. If all you're using it for is to find a slope at a certain point, this is the place to stop. But I'll try to make note of that in the directions. Anyway, that's it for quotient rule. It's not bad, it's just a little worse because order matters. All right, talk to you guys later.